So welcome to day 2 of Ignite. I hope you had a fabulous day 1. And throughout the week, we've really got a lot of stuff planned for you guys. To kick off today, we're here to talk about the Azure virtual machines, the infrastructure as a service, and we're going to get a bit of a deep dive into this. So my name's Drew McDaniel. I've been with Azure for 3 years, working on our infrastructure as a service since we brought that on board. I've been at Microsoft for 18 years, and so we'll talk about how we bring a lot of these capabilities of virtual machines to you as either a developer or an IT pro. I'll also introduce Mahesh here.
Yeah. Hey guys, I'm Mahesh Tyagarajan. I'm a program manager in Drew's team, and I've been working on Azure for about 2 years now, 6 years in Microsoft, and focusing on bringing the virtual machine experiences.
Great, thanks Mahesh. So today we're going to cover, start off just a quick overview. What is IaaS? We have some later sessions today that goes to a broader view of IaaS, and so if you're new to infrastructure as a service, you can actually go to some of these other sessions a bit later. To get a fuller detail, we'll just touch on this basic high level. We're going to talk about what IaaS is and what is IaaS v2. IaaS v2 are also Azure or IaaS virtual machines under the Resource Manager. Is something that we introduced public preview last week. We're going to spend a lot of time talking about that, going into the advantages of what that brings to the platform, how templates, which is part of the virtual machines in Resource Manager, adds to the picture. Security and cost management, some things that come with Resource Manager, as well as other enhancements we're doing in the platform. Then Mahesh is going to walk through a set of these complex applications, how you actually build those out in templates. If there's any problems with building out those templates, I'll talk through some of the debugging, how you actually debug those deployments. And finally, we're going to wrap up with the unified Azure stack, which was announced yesterday during the keynote. The fact that we are bringing together the Azure cloud-first focus with the on-premise stack that we have with System Center and Windows servers. So you have this unified Azure stack. And this is a step in this direction. And we'll talk about how we do this. And in fact, the vast majority of everything you see today is available now in the Azure cloud, public cloud. That is coming to the on-premise environment in very near time. So at a high level, really, what is infrastructure as a service? Infrastructure as a service is really a set of compute, networking, and storage resources. When it comes to compute, it's really the virtual machine and a set of virtual machines extensions. Extensions are a unique capability of the Azure platform. It allows you to extend the functionality of that virtual machine, and we'll show you a little bit about how you do that, the different variety of options that you have for extending the virtual machine. Storage is really the basic storage for your disks. So in Azure, we use the Azure Storage Service that has a functionality of blobs, tables, and queues. We use the blob functionality to store the VHDs for the disks. And the blob functionality can either be a standard storage that has different levels of replication. You can have locally redundant storage or geographically redundant storage. We also have premium storage, which was just introduced into general availability about 2 weeks ago. And we'll talk a little bit about how premium storage can actually leverage that in your IaaS virtual machine. And then there's a later 400-level session that goes into really deep dive on premium storage, exactly how you use premium storage, where it works for the specific workloads, and how to configure it. So we're just going to touch on that during this session. And then finally, your networking resources. So with compute and storage, then you have your networking pieces. This is a virtual network, your network interface cards, your load balancers, your IP addresses. This is what allows you to connect back to on-premises through hybrid connectivity, whether that's through a VPN solution or an express route solution. A lot of capabilities around the networking, and again, we'll touch on that. And we've got some references to other sessions today and through the week that really go into the networking capabilities in a lot more detail. So what we want to look at is with IaaS, like I said, we've just introduced what we call IaaS v2, or IaaS under the Resource Manager. And I want to look a little bit about what we have today, so if anybody's used the virtual machines today, and then how this changes a bit going forward with the Resource Manager. So today you start off with this notion of a cloud service, which is really the compute aspect of the machine, as well as some of the networking, a storage account, which is what contains the blobs, and that virtual network. So if you have a VM in here, the VM can have an IP address, and then it connects down to the blob for the disk, and then a virtual subnet for the virtual network. And then finally, there's a load balanced endpoint. And this is Azure as it exists today. You'll hear us talking about this as our classic set of resources. In the resource provider model, sometimes you'll see messages about classic compute, and this is what we're calling our classic compute. Now, Resource Manager, on the other hand, changes it a bit. You have a resource group and then a set of resource providers that provide these resources. Now, so you can see this as decomposed. It's more of a separated, componentized model where you have storage accounts separate from VMs. The NICs are separate resources. The VNets are separate resources. This allows a lot more flexibility. As we actually look into some of the templates that we have and the configuration, it adds a lot more functionality and flexibility. But when you're actually deploying these, you don't want to just have to manage these as these individual resources. And so the resource manager actually has this concept of dependencies. So I say, hey, the VM is dependent on the storage account, because if the storage account isn't there, I wouldn't have a place to put my disk. The VM then references the network interface card, because it needs to have that network interface card to run the VM. The network interface card references the external IP address, the virtual network. The load balancer references back into the NIC if you're using a load balancer. And of course, the load balancer if you want to have an IP address on that. And so these references and dependencies are articulated in the model when you actually deploy these VMs. And then the resource manager is the thing that goes through and deploys these resources, does as much parallelism as possible, while also respecting the references to make sure that the dependent resource is fully deployed before the subsequent resource is deployed. The one thing that is, and you could also then connect in here, the network security group can be applied on the network interface card, or the network security group can also be applied on an individual subnet. So you can actually set up subnet ACLs as you want, or you can set it up to individual virtual machines. Two pieces that are still coming into this, in the Resource Manager v2. Resource Manager v2 is really, the control plane is in public preview. The resources that are deployed, though, are full GA resources. So if you use the new Resource Manager, deploy those virtual machines, deploy your storage account, the same SLA applies to those virtual machines as would apply if you deployed through the classic model. Part of the reason why this is still in preview, we'll show a little bit, the portal functionality, the graphical user interface functionality is not fully developed, and there's a set of key features that are still coming, specifically VPN gateways and ExpressRoute are two pieces that are not yet available on the resource group functionality, will be coming very soon. Now, as I mentioned, Premium Storage. Premium Storage was announced in the public preview late last year. We went into a broad preview at the beginning of this year and came into GA just 2 weeks ago in mid-April. This brings a high-performance storage subsystem to the Azure virtual machines, very low latency and high bandwidth connectivity. You can get up to 64,000 IOPS on a single VM, 50,000 IOPS on a single disk, and very low latency, 5 milliseconds for no cached operations, and less than a millisecond for cached operations. So what this really means, and a nice diagram here, if you look at the virtual machine, so you've got the virtual machine, the compute layer up there, and what we've got demonstrated here is a set of disks. So the two disks on the left are your persistent storage disks. Anything written to those disks will be stored in persistent storage in the back-end Azure Premium Blob Store. The one on the right is the local disk, or your temporary disk, your ephemeral disk. Things written there are for the lifetime of the VM, but if the VM were to have a hardware failure and need to be moved to a new node, that local disk would be reset and recreated. Typically, we set up things like your page file on the local disk. Now, what we have here is each disk has a certain provisioning, so you have a provisioning amount for that disk that varies based on the size of the disk. The reason for this is the back-end storage is all SSD-based. As you have a larger amount of disk space, we have a larger amount of IOPS that we can bring to bear for those disks. Our largest disk is at a terabyte with what's called a P30 disk. It gives you 5,000 IOPS for the disk, as well as 200 megabytes per second. You also, though, have this SSD provisioning. So within the local virtual machine, there's local SSD. And we leverage that local SSD for caching of operations if the disk is configured to be cached. So if you see here, your cached disk will come through and will go through the SSD provisioning. A cache miss will go out through the network, and a cache hit would go to the local SSD. Now, to put some numbers with this, we'll use an example, a standard DS1 with two P30 disks. And what we see here is you have your different configuration. Your IOPS for the disk are defined based on the size of the disk. Your IOPS for both the network at the bottom layer and then the local SSD is dependent on the virtual machine size. So as you can see here, our DS1 is a single core. We give a 4,000 IOPS per core, effectively, in the local SSD cache, and then a little over 3.2 thousand IOPS per core in the network. And this is so that as you grow your virtual machine, you actually are able to use more of the local NIC, more of the local SSD, and so that cache capability will continue to increase. And that's where you'll see greater functionality, greater speeds if you're using, say, a DS14, which is the largest D-series VM, as compared to a D1. You can also then leverage this to actually start out. You can set up your configuration as you want, and then scale up your virtual machine as you need to get more performance. Now, the building blocks of a virtual machine, as I mentioned, is really this notion of your images and your extensions. So when it comes to images, we've got, of course, a set of Windows images that you would expect to see in a Microsoft product. We have a large amount of Linux and open source images from Ubuntu, from CentOS, CoreOS, SUSE, a large number of partners we work with to bring Linux to the platform and that functionality to the platform. Set of application, and this is just a very small subset, but the application workloads, whether that be from the Microsoft side of SQL or the third party, whether that's Oracle, IBM, a vast array of application prepared images that are available in the portal, whether that through the core platform, and then there's a marketplace that extends that to hundreds of additional images. And finally, there's a set of images that come that we call our community images. These come from a solution called VM Depot. And again, these are primarily our open source set of images where customers will upload those. You can use those images as well for your base machine. Now, with that, you have your base machine. You can add on a VM extension. So what a VM extension is it's a curated set of software, software payload, that we can bring down to the virtual machine. You pass in a set of configuration to that software, and that then runs that within that virtual machine. This allows you to very simply extend and do things like antivirus, which is the Microsoft anti-malware solution. CloudLink does an encryption of your virtual machine. Symantec, again, an antivirus. So it's very easy. Just click a button in the portal or a flag in the command line interfaces to actually enable these extensions on any of the operating system. And again, most of these extensions, there'll be a set of extensions for the Linux side of the house and a set of extensions for Windows because they tend to have different binaries. The next place you see a large amount of use of extension is these kind of deployment configuration. So we've partnered with Chef, with Puppet, Octopus Deploy. We have some tools from Visual Studio and Release Management. This allows you to do configuration of that virtual machine. Typically, this is in VM configuration through this extension. Typically lays down an agent, passes the configuration that agent needs down to the machine to run. Configuration, you'll see this in some of our templates for PowerShell and custom script that allows you to execute individual scripts on the machine. And then we continue this with a set of other things that are used. Again, we use this pretty extensively in the platform. Visual Studio integrates this to actually start up the debuggers. We use diagnostics agents, monitoring agents. Our support team uses this for recovery, so the access extension will go in there and allow you to reset your password, to reconfigure the firewall, all through this native built-in model, such as very simple to leverage. So what I want to do now, I want to kick off a quick demo. And what we're going to do here is just to start to show the power of the resource group solution. So what we have here is I've got a script. So this is a script that highlights our existing cloud service, existing classic model of creating a virtual machine. We just create the cloud service, go through here, and then we're going to create 40 virtual machines. We're going to put these 40 virtual machines in a single cloud service so they can be highly available. And we're going to go ahead and kick this guy off. And it's going to go through, creates a storage account for the virtual machine, and it's going to time these. So while we're doing this, I also want to show you, we have then a scale demo. So here what we have is leveraging a template that is used for Azure Resource Manager. Now, we're going to go into a lot more detail through this template, what it provides, but at a very high level, the template provides a set of parameters that you can supply, a set of variables that then are configured into here, and then used in the template, and then finally it deploys resources. And this is a fairly straightforward template. We're just going to deploy a set of VM resources. We're also going to use this template parameters file. This supplies the configuration information that the template needs. Again, you can go through this interactively, and we'll show you a little bit about that later on. But again, we're deploying the same VM size. We're deploying 40 VMs in East Asia. And we're going to kick this off through PowerShell. We're going to create a demo. Let's do a DrewM demo ignite. We'll create a resource group. The resource group is what's going to hold all of the resources for this deployment. I'm going to use this, and then we're going to kick off this. We're going to kick off that deployment. So here we say the resource group name, the deployment name. We're going to select the resource group name, which is the one that we just created. Let's put this in here. And then we'll just use that template and the template answer file as shown before. It quickly does a validation of the template, and is going to kick this off. So we're going to let this run. As I said, this is going to do the timing of both of these, and so we're going to come back here in a little bit and see how the two different stacks proceed at deploying 40 virtual machines. So with that, I'll change back over here and hand over to Mahesh.
All right. Cool. Thanks, Drew. So I think we just saw a glimpse of the template files and how to simplify deploying large-scale VMs. What we're going to go into now is a brief introduction into some of these concepts so you know what we're talking about. This is the new announcement that we made over last week. This is the introduction of the compute, network, and storage stack under Azure Resource Manager. What this is going to do is it's going to fundamentally simplify how you deploy applications on Azure. And that's the key message. So let's get started. I'm going to go through some basics and then talk about what are the advantages of the new platform. So the first concept that we want to talk to you about is resource groups. Resource groups are just software containers that allows you to package or manage resources as a single entity. The reason why you would want to think about resource groups is resource groups gives you this management entity as a whole. A good example would be if you have, let's say, 40 virtual machines or 100 virtual machines as a single entity today. If you have to go delete them, you have to write a script that loops through and finds all those resources and deletes them. But in this new model, we provide this management entity as a whole, so you can actually have a resource group and just say delete. It's going to delete all the resources under the resource group. So it is pretty powerful. And there are other pivots around resource group, specifically around billing and role-based access control. So you can actually apply billing tags, and we'll be going into great detail in the second half of the slide about how you can use this for cost management. But you can configure a tag on a resource group, and that tag will actually propagate through the bill and be available at the end of the month. So if you have, let's say, a resource group with 40 VMs, it'll actually, the tag that you configure, let's say department equal to engineering, will show up at the end of the month in your billing CSV file. So it allows you to build rich pivot charts saying, how much did my IT department spend? How much did my engineering department spend? You can actually do all of that using the tagging capability. And role-based access control has been a feature that has been asked a lot of times from the IT pros and the enterprise customers. This gives you the flexibility to say, here are the permissions for a SQL admin. Here are the permissions for a database admin. You can actually set these policies and configure them. We have some demos and some deep dive going into the second half of the session. Okay. Now, when you think about resource groups, one of the common things that people think about is like, how do I use them? Like, how do I actually place my application into it? The most common scenario that we talk about is like, hey, if you have an application that has an identical lifecycle, so you're spinning up, let's say, a web tier VM, and then you're putting up database at the back end. That's a very simple VM. You're doing some dev and test. It's a very easy example to say, let's package that in a single resource group because it has the same lifecycle. Now, but if you think about lift and shift apps that run on the cloud for a very long time, the way to think about it is, a good example would be SharePoint, which we'll go deep dive a little bit later. But if you have a 4-tier app and you know that your SQL tier or your database tier is going to be around for a very long time, it is a good practice to place them in a separate resource group. Another advantage of placing them in a separate resource group is that you get the flexibility to configure different role-based access control policies. You can say, That resource group with the database resources gets access only to my database admin. You can do the same for networking too. You can actually place the networking resources in a separate resource group and say only my network admin gets right access to that, so nobody else can change it. So you get that flexibility of billing, you get the flexibility of the different admin providers in your enterprise, all of that. So think about the lifecycle, think about the billing, think about security and role-based access control when you plan this. Now, another interesting part about resource groups is we will, in the future, support the capability where you can move a single resource from one resource group to another. So this gives you the flexibility where if you made a mistake of actually placing an entity in the wrong resource group but you want to move, we will make sure that it's supported. But I want to say that it's not supported now, but it'll be supported in the future, so you actually have the flexibility to move resources between resource groups. Okay. So you guys got a brief glimpse of the template file. Now what we're going to talk about is what do they really mean and what advantages does it offer for me as an IT pro. So the first thing that, just briefly about templates. Templates are idempotent. I'm not just saying the templates are idempotent. The APIs that are backing these templates, the APIs that allows you to create a VM, allows you to create a virtual network are idempotent. What I mean by that is if you actually submit a VM, go create it, say, let's create a standard underscore D1 VM. You get the output of the VM and you post it back, the platform will accept it and will actually process it and say everything's good to go. So the platform is completely idempotent to any request that you want to make it to it again and again. So the templates themselves are idempotent, so you can actually resubmit the same template file again and you'll get the same output saying everything is good to go. The second part about the template is it offers orchestration. And orchestration, and we'll talk about two things. Orchestration is offered at two levels. First, at the infrastructure layer. So when you talk about the infrastructure layer, if I'm deploying an app, I have to start with, okay, I need to set up my storage. I need to make sure the disks where the VMs are going to be placed is ready to go. Then I think about my network. I create my virtual network. I set up my security groups. I configure my load balancer. I have everything to go. Then you think about, okay, now I need to spin up my VMs, and I need to spin up a set of AD VMs for my domain controller. I need to spin up a set of VMs for my database. I need to set up a VMs for web tier. So you have this whole thing where you need to orchestrate step by step. And if you had to do this today, you had to write these long PowerShell scripts that would actually loop around, know when a resource is created. But all of that flexibility and the dependency expression now comes through a template file. You get the simple flexibility of expressing the orchestration or the dependencies between the infrastructure layer right in a single template file. Now, we don't stop there. We briefly talked about extensions. Extensions now, we talked about Chef, Puppet. We also have support for DSC. We also have support for custom scripts. Like you can author a custom PowerShell script and actually go ask that script to be run inside the box and wait for an output. So what this means is if you actually have two VMs, you can express a dependency between script 2 running on VM 2 can actually wait on script 1 running on VM 1. So you're now not just expressing dependencies between infrastructure, you're saying my script files running on two completely different machines actually has a dependency between each other. So don't run the script 2 till it's actually done on script 1 on VM 1. So you have that complete flexibility. Now, the another key question about this is like, what if I make a mistake in my script? What about rollback? Are you going to delete it? So at this point, the platform doesn't support automatic rollback because we believe that setting up a SharePoint sometimes like 2-hour job. You made a very small mistake and you're like, wait, I have to go. If I roll it back, do I have to do it 2 hours? Spend another 2 hours? So what we support, given the platform is idempotent, what you can do is if you actually made an error in your script, you go modify the script, just resubmit the template file all over again. The Azure Resource Manager will detect that, the first 1 hour of the work of setting up 10 VMs is actually complete. It'll start from that point onwards. It'll actually know because all the APIs backing these resources are idempotent. So it'll actually progress from there, which is good. So in case you make a mistake and you're like, no, I don't really want to wait, the good way to do that is you have a resource group which you can just delete and then start from scratch again. So it's a very powerful model from that standpoint. Now, another key capability about templates is it's not just for compute, network, and storage. It extends itself to all Azure resources under Azure Resource Manager. So if you want to have an app that uses virtual machines and websites, you can actually build a template file. You view that as an application model going forward versus just like pieces of infrastructure that you get from Azure. It's about building an app, and you build this file which will allow you to construct your app and reuse it again and again. It's repeatable. So what do we think the template files as? We think the template files are your deployment files for your application on the cloud. So those are files that are checked into your source control. You keep them and you use them again and again with the right set of parameters whenever you want to deploy. And the templates themselves are repeatable because we can parameterize a lot. And we'll show some samples of how to parameterize. So the more you parameterize, the higher flexibility that you have in how you reuse them again and again. Okay. Now talking about virtual machines, and we kicked off a demo, and we'll go over to look at some of the improvements there. The first thing here is that we've fundamentally improved how we provision virtual machines and how fast we provision virtual machines. So we have introduced the capability of provisioning massive and parallel deployment of virtual machines, and we'll talk about that from the sample. But now you can actually provision 50 or 100 virtual machines in parallel inside the same construct called an availability set. Earlier, you used to have this problem where if you had to create 50 or 10 virtual machines in a cloud service, you'd have to wait for a couple of minutes before you added the second VM. That is removed. So you actually get parallel deployments into a cloud service, so the provisioning times of your app in the cloud is much faster. We've introduced the capability for 3 fault domains in an availability set. So for all quorum-based workloads, for example, SQL Server Always On now gets 3 fault domains, which means it's physically on 3 separate racks or redundant racks to ensure that you actually have a high availability for your application on the cloud. So you actually get 3 fault domains. We've made some improvements in the VM extensions model for providing custom URLs or running custom scripts. We've also added support to make sure that we support the SSH to RSA key format as well. So how many of you know about Azure Key Vault? Have you heard about it? Okay, very small crowd. So Azure Key Vault was a recent announcement that we made. It actually provides the capability where you can actually get increased security over your keys. You can make sure that your applications that are running inside the VM don't have direct access to the keys or to the key vault itself. And these keys have 2 options. One, you can actually put the keys in a software-based model, or you can actually put them on a level 2 certified hardware security module or an HSM and actually back them on the cloud as well. So what we have done is we've gone ahead and integrated the compute or the virtual machine layer directly with the Azure Key Vault. So what you're seeing here on the right is a sample of how to go create a key vault. So if you look at the type, it says Microsoft.keyvault/vaults. So this is the way you actually specify in a template file about how you go and create a key vault. So this creates a key vault. Then you can use our PowerShell commandlets to push your keys or certificates into the key vault. And then once you're done, this is the JSON for the virtual machine. What you do here is if you look at the secret section there, right there, you can actually reference the vault certificate. You can specify just this is the vault that I need the certificate from, and the platform between the key vault and the compute provider, they actually talk to each other and make sure that the secrets are actually passed right into the virtual machine. So you are responsible just for pushing the certificate into the key vault, and then any number of virtual machines that you want to spin up, you just reference the particular key or the certificate, and you're not in the business of uploading it every single time into the VM that you want, or you're not uploading it every single time into the cloud service that you want. So you get the flexibility of pushing it in one place and reusing it all over again. So the idea, just to show a quick animation of how it works. So you have to create a key vault, push your keys to the key vault, it automatically goes into the system, and then all that you have to do is when you create a virtual machine, just reference the certificate while you're deploying the VM, and the platform takes care of moving the keys into the virtual machine. All right. So let's talk a little bit about, okay, now we talked about the deployment advantages, how it simplifies your deployment model. Now what happens after I've deployed? So there are 2 ways in which we think the template model is going to fundamentally simplify your deployment experience. One, purely from a create time process. So if you actually have an app which is very complicated to deploy, you can use the deployment process and then move on to your other tools. You can go and use your PowerShell commandlets. You can use the imperative APIs. You can use the Azure CLI. You can use the portal. You can use all of those different tools to go and toggle or change and deal with those resources. You don't have to continue to use the template. So the template could be a one-time, single-time deployment model, and then you have the imperative APIs to deal or the imperative commandlets to go make the changes on the resources. The other advantage or the leverage that you have is that you can continue to use the same template for your upgrade and updates as well. For example, if you actually say, let's say you deployed a 2 VM template and you're running it. A month later, you're like, hey, I want to add a couple of more dev and test VMs because it's helpful for me. All that you have to do is take the template, just modify, add the parameters or add the right sections for adding 2 more VMs, just go deploy again with the right parameters file. We are going to detect that those 2 VMs already exist, and we just do the upgrade for the next 2 VMs. So this is the idempotent capability. So you actually have, you're dealing or working with the platform or telling the platform or interacting with the platform just using the template files going forward. In terms of manageability and auditing, we have the flexibility where, obviously just like any cloud platform, we continue to make sure that any tasks, any actions that are taken on the platform are audited and are stored for 90 days. So you'll actually know who made the call, on what resources they make the call on, what was the outcome of the call. All of that will be stored in the platform. We have tools across the board on all our PowerShell, CLI, portal, everywhere to go look at these audit logs. Another key capability that we do have on the platform is the concept of management locks. So when you have a set of resources in a resource group, you are given the power to just in a single click go delete the resource group. So it is pretty powerful. So the way you can protect that is we provide the capability of a management lock where you can go lock a particular resource in a resource group and say, hey, do not delete this resource even accidentally. Require me to explicitly unlock a resource before I go delete it. So even if there's another user in your subscription who has the privileges, accidentally tries to delete a resource group, but if you had locked your storage account, it'll protect that and make sure the storage account is not deleted so you never lose the data. So you get that flexibility. Okay. In terms of how do you get started, this is a new technology, new capability, what we've announced. So what we've done is we've built a huge collateral of templates for you guys to go get started on. So we've pushed this, and I'll show you how to get access to this. We've pushed the templates up on Azure.com. You can actually go fetch these community templates up there, and I'll show you how to get it. We've got about 70 or 80 different templates up there to show you the different capabilities that are supported. All of these templates up here are actually backed by a GitHub repo. So you have these templates on a GitHub repo where you can go download, fork the entire repo, get access to it, get all the templates that you can go play with. And this includes all the different categories that we have, and I'll show you some of the categories as we go along. And these templates right now are contributed by the community. We had MVPs contribute to this already, and we had, it was also contributed by Microsoft people. And you guys are more than welcome to fork, send us PRs, and contribute to this template as well. As I mentioned briefly, these templates, there's deep integration with all the Azure services, so do think about them. We'll push more templates up here that integrates with websites and SQL databases as well. Okay, let's transition to a quick demo. All right. Let's go navigate up to the simple game. All right, the first thing that we are going to do is get a quick peek at a simple VM. This is just a single VM that is being deployed and what that template file looks like. So if you look at the left corner, Visual Studio offers this good flexibility of getting a JSON outline of what the template file looks like. And what you're seeing there is the set of parameters, a set of variables that are defined in the template, and if you go down, it'll actually show you the set of resources that are being created in the template. And the parameters are nothing but the values that makes the template highly repeatable. So this is how you can actually take the same template again and repeat it again and again. So you can actually get multiple VMs. You change the parameter values, and you just get multiple VMs again and again. Now, a good example here is that I'm using a new storage account name as one of the parameters. Another advantage about the parameters is you can actually have back it by a parameters file. So you can actually have a parameters file that backs this template. So you can have multiple parameters file, one potentially for dev, test, or production, and actually use the same different parameters file for going and deploying it. So you have a single template file backed with multiple parameters to go kick it off for different environments. Now let's look at the variable section. So the variable section are nothing but just what it says. It's like runtime constants that are available that you can configure that you don't think needs to be parameterized every single time. For example, one of the things that I've done is like I've put the value for the storage account. I know that I'm not going to change it. I don't need a geo-redundant storage account because I'm doing some dev and test, so I go use that. The additional capabilities that are there in the template file is certain language capabilities. Like if you look at it, there's resource ID, there's skincat. These are language capabilities inherently supported for you to build richer templates. So you don't have to, accept everything from the user, but you can construct these values on the fly based on the inputs that are given and based on the values that you pre-configured. So you can construct these by these language capabilities that we have. In terms of the resources themselves, there are the few resources that we talked about, the building blocks, if you will. The storage account, where you need to go place the disks for the VM. Then we have the public IP address. This is the IP address that is going to be attached directly to the NIC. This is going to allow you to get RDP connectivity or SSH into the box. Going forward, we're giving security by default. So all VMs in Azure has to be created in a virtual network in the new model. So by default, you place the VMs in a virtual network, and they will not be handed a public IP address by default either. So you have to explicitly ask the platform to say, hey, I want this VM on the internet. I want it to be attached to a public IP, and that's how you get access to the VM. Otherwise, it's going to be inside a virtual network, your own virtual network, and it does not get secure. It does not get placed on the internet. So you get security by default. And as we mentioned earlier, the network configuration of the VM itself is separated out. It's going to be contained in a network interface object. And the good part about the network interface object is that the life cycle of the network interface object is not tied to the VM anymore. They're separate. So when you actually delete a VM, the network configuration doesn't get deleted. So if you do a very rich network config of a network interface that uses a security group, configures the right policies, uses a public IP address, uses a set of ports, all of that configuration can actually live, so you don't have to delete it. Then you use it for another VM all over again. So it gives you the flexibility of pre-configuring the network interfaces. And if you think about the enterprise ID admin scenario that we talked about, you can have the network admin prep a set of NICs available for the virtual machine users to come online and say, just pick one of the NICs that are available. You can only attach a NIC, but you can never create a NIC. You have the flexibility of doing all of that work by the basic building block nature that we have built out on the platform. And here's the virtual machine definition that we looked at. It's pretty straightforward, very similar to what we've done before. OS profile that defines the username, password, the size of the VM, where does the OS configuration live, and all that we do is that we do a reference of the network profile. And one other important part that I do want to touch on here is the dependency capabilities. And as we mentioned earlier, if you look at the dependencies, this virtual machine, we've expressed a dependency to state that this depends on the storage account to be available, and this depends on the network interface to be available. And you just expressing here will make sure that the platform detects the dependencies and executes them in the right order, so you don't have to worry about it. Okay. So let's quickly jump to just executing this from portal. So I briefly mentioned that I'm going to show you how to get it. This is azure.com. Go to Community, Templates. This is going to take you to our Azure Quick Start templates. We have a lot of templates up here for you guys to go look around and play. A good way to do is you can go search for a particular template or a variable that you think. So for example, I can say Windows, for example, and it's going to give me all the templates that have the Windows tag in the name. And what we're going to do is we're going to go ahead and deploy a simple VM right from here. So let's go select that. While that is loading up, as I mentioned, this is backed by a GitHub repo. You can actually get access directly here. This GitHub repo is organized by 101 and 201 levels. 101 templates touch on the basics of creating a VM, creating a public IP, how to attach a NIC, and all of that. The 201 templates go a little bit deeper, use richer capabilities, configures extensions. Then you have additional very complex application templates that goes into how do you set up Active Directory in a HA mode, how do you set up SharePoint, how do you set up an HA, non-HA. It goes into setting up open source applications. It touches a lot of these different services that are available on the platform. And we'll be adding more as we go along directly up here from the community. So this is deploying a simple VM. What we've done is we've integrated this directly into our portal, so you can actually deploy a VM right from here in the portal. So what this is going to do is it's going to fetch the Azure deploy.json from the GitHub repo, directly pull it into the portal, and it'll actually show up a custom UI where you can enter the parameters for the template and just deploy it. Let's wait for it to load up.
So Mahesh, while this comes up, what if you wanted to use your own template that you had on premise? Could you use that in the portal as well?
Absolutely. So the simplest way to do that is you can just take the template as is and actually paste it in the template file, and I'm going to show you how to go do that. You can actually construct a custom template, place it directly in the portal, and say, hey, go deploy. So you can do custom deployments right from the portal. You don't have to need this integration. You can just go create a new template deployment and deploy right from the portal as well. And we have richer configuration on other tools, so for PowerShell as well. So you can actually save the file locally on your box, use PowerShell.
As I was using a little earlier, that was the PowerShell version.
Yep.
Oh, there we go.
There we go. So this is the template file that was actually sitting there. It custom loads directly here, and as you can see, it has the same parameters section, the variables that we looked at earlier, the set of resources, and the exact set of dependencies that we talked about. Now what you get is you can go save, then you can go edit the parameters section, you can enter a set of values.
So these parameters here came directly out of that template then, right?
Yep. It's actually custom loaded, so based on the parameters that you guys define, it'll actually be available. So I'm going ahead and...
This template doesn't have them, but the template can have default values that if you don't select anything, you'll just take the default values. Here you got an enumerated value here, so different versions of Windows.
Yep.
And you really have that flexibility in what you want to do in the template. You can design, you can start with what we have, customize that, and give that to your operations team and say, always use this template. That allows you to do what you need to do, whether it's dev, test, and constrain them as appropriate.
Yep. All right, I'm just creating a custom resource group to go deploy that. And I'm just selecting a location. Let's go pick East Asia. Great. So this is going to go ahead and create the VM. The important part about the resource group is that resource groups actually, even though we pick a region, you can place resources in a resource group across the globe. The idea behind the resources, if you have a highly available application like a database that you want to go deploy in, let's say East US, and you want to actually back it up in West US, you can deploy that app as a whole in a resource group. So the resource group actually will have resources that spans the entire region, entire globe. Something to remember. Okay. So while that comes up, I'm going to go switch back up here and show you that the 40 VM template deployment.
All right, let's see which one won. So this is the one from the resource group using the new interface. Oh, wait.
Yep.
Is the old stuff still not even done yet?
Yeah.
Wow. So 40 VMs, it's been running for, gosh, about 39 minutes in the worst case?
Yep.
Where if you go over to the other side, where are we at? How long did it take to complete deploy
like 4
those?
minutes.
17 to 21, about 4 minutes to deploy 40 VMs in a high availability set.
Yep.
Pretty slick.
Yep.
Again, these templates, I don't know if we have the 40 VM template up there, but there's other templates up there that use the mass deployment to configure the number of VMs that are they're part of the GitHub repo.
Yeah, absolutely. So we have these templates available. All that you have to do is to take one of these templates, just change the value. That you'll find like number of instances. You can just change the value to 40 and it'll deploy these big VMs for you, big sets. All right, cool.
That's awesome.
I'll let you take over, Drew.
Okay, so Mahesh has walked us through kind of the intros of the template. Let me click over here. Here we go. And we talked a little bit about some of the functionality that Resource Manager brings. I kind of classify this as like our enterprise resource management functionality. The first one is a set of tags. Now, you can place tags on either resource groups or resources in your configuration, and that then applies to those machines. You can leverage that to view those resources within the portal. Additionally, those tags will flow through and be integrated into billing. And that allows you to do some really advanced things. You can actually see what all the charges are for, say, your marketing department versus an engineering department, or however you want to configure that. And we'll actually show those. So these tags allow you, you have complete flexibility. Your set of taxonomy for tags is at your subscription level. A set of examples that we've actually talked about here, maybe a tag for notes if you want to put a little simple note with each machine or resource. The creator or owner of those resources. Department and cost center or project name is a very, very common thing that we see as people start looking at tagging. And then also environment, production, pre-production, dev, test is a very nice functionality. And so this, again, is part of the resource manager capabilities. It exists for a lot of other resources, but this is the first instance where for compute networking storage that these tags flow in under the IaaS v2 kind of set of things. In addition, you get rich RBAC capabilities within the Resource Manager. So RBAC stands for Role-Based Access and Control. It's fully integrated into Azure Active Directory, so you can define groups or individuals, service principals if you want to do some automation, and you apply those to either, again, a subscription, resource group, or resource, and that always propagates down. This enables you to have a much more control of a subscription as compared to what you have today in the standard Azure, the classic environment. You basically have full control or nothing, which made it very, very challenging if you want to have an operations team that only manages a set of VMs, you want to have a set of read operators. Now you can specify read access, contribute access on individual VMs. Gives you that flexibility, and we'll show you that in just a moment. As I said, this actually goes from subscription down to the resource group, down to resources. The default configuration is contributor, owner, or readers. You can also do customized roles. The customized roles is coming in a very soon release, but it allows you to actually do things like, as Mahesh mentioned, maybe create a network operators group. And so you actually configure a set of resources, the virtual networks, the NICs, only for the network administrators to actually do the configuration. It allows you to do things like only allow egress for specific workloads, and it allows your IT operations to actually set some policies and controls around who can do what based on the type of VM. And so, for example, we use this a lot in our Microsoft IT organization. They have specific requirements for high business impact containing VMs, and they have to be on specific virtual networks that have specific intrusion detection services and such involved. And so it allows that separation of duties. The RBAC itself, the access controls are set at the API level. So all of our APIs are REST-based APIs, and so you can set permissions on the subscription here. So if you're setting it at the high level, and then it applies to everything below, you can set it at the resource group level, which is represented here by name, or the individual resource. And so it allows a lot of flexibility, again, baked directly into those APIs, setting those different permissions on the system. So let me show you real quick what this looks like. So here we've got the portal here. I've created a resource group. I want to actually, let's say this resource group, I want to delegate down to an administrator to be able to create resources in that. In the portal, we've got the little people icon for access. And so I'm going to delegate, and actually I'm going to show you real quick. I've got a separate login here using IE. I'm logged in here. This is using my Microsoft account under a Hotmail address. And here I have no resources that I can see. Now if I come over here and now I want to add into here, I'm going to add to this resource group. And I want to select a role, use a default role of contributor. Again, there's additional advanced roles that you can configure in here. I'm going to add my Hotmail address. It's going to go find that. So this is going to add my Hotmail account to this existing subscription, specifically not for the subscription as a whole, but only to the single resource group. So did that apply? There it is. And now, if we go back in here, again, I'm logged into my Hotmail account. Here, if we do a refresh, we should, let's see if it pulls up immediately. Let me refresh here. As I come in and refresh here, you'll go in there, log in, looking at the specific subscription here. Now, this is mapped under your AD tenant, and so my internal subscription is under the Microsoft AD tenant, and so even though I'm logged in here as my Hotmail, it says, hey, there's something in this other AD tenant that you have access to. I select over here to log in and look in that AD tenant, and now if I go into that resource group, I do see that the RBAC tag resource is there. I can now go through and create VMs in here, do whatever I want in that resource group, and again, that RBAC will persist down, or inherit down into that resource group. Now, similarly, if I want to do tagging, same way here, you can actually come on here, nice little tag you specify. I created for the subscription a set of tags here. I've got the project, and so I'm going to say, this project is for demo purposes. And we're just going to save that. And that's going to add that tag into that resource group. And now when I see that resource group in my bill, it's going to have that tag applied to that. Okay. So we'll come back and show a little bit more on how this applies. Now, the tagging and the permissions, a lot of times permissions is good regardless, but it starts allowing for a little bit more advanced cost management. You can actually say who's doing what at a finer grain. You can force these tags that people use, and it allows you to get usage information. Now, today, if you want to get usage information, you can go to the accounts portal, you can download a CSV file and process that offline. It's a little bit cumbersome. What we are introducing We're introducing this now as a private preview, and there's actually, so I don't forget, I'll mention it at the end as well, there's a email address down here at the bottom, Azure billing feed, that you can send us information if you're interested in applying for this private preview. We'll have a public preview here shortly of these functionality. The two key functionality here is a usage API. So with this, you will be able to query the Azure to understand the usage of a subscription on an hour-by-hour basis. So you can call this API. It gives you a JSON format that can be then processed by automation. You can then separate out based on tags or any other things that you want in here to get the usage of that subscription. Again, this is integrated under the Resource Manager, so you have native RBAC on the usage API, and so you can give a specific accounting group the read access to that part of your subscription. They can access that and get usage information, not get other information. If you want to go further than that and actually say, okay, now how much is this costing me? The second API that's part of this kind of preview that we're kind of considering our IT financial management is Rate Card API. The Rate Card API gives you the rates of each resource, gives you your pre-tax rate. Right now, it does not support EA offers. That's coming shortly. But you can see where this is leading, so you can actually get the how much individual entities are costing me. I can actually see how much the cost is for project demo needs, and you can quickly see that information, all fully automated. Now, that's great. You can do this yourself. We also have a lot of partners that we're working with. And so I want to highlight two partners that are working with very early here. Cloud Cruiser is one. Down in the expo, you can catch them in booth 220. They leverage the usage API, are helping us enhance that usage API so you can get detailed information about your usage directly through that software. It leverages the tagging capability, and you can see them for a demo of that. Again, this is very new, very early, and so we're seeing some iterations on this. As I said, we're private preview right now, but you can check that out. Second, Cloudant is also working with to do this tagging and utilize the usage API. Again, gives you some information about your actual cost over time, provides some recommendations, potentially upsizing, downsizing VMs to get you some cost optimization. And again, you can check with them in the expo, booth number 4, to actually get a demo of what they have, how they're going to use the usage API, and just some great tools for you to use. And then quickly, we'll just show, again, what this ends up looking like. So what I've pulled here is from the usage API, you can get your billing. So first off, your billing tags I wanted to show. So here, what we have is our CSV file that we've downloaded. This is what we get today. And what you see here, newly added, is a tag section. And so it breaks down within the various resources. Here was set up with display name of virtual machine, and then a test tag. And then we've did some Excel formulas here to actually break those out into individual columns, and you can further do pivot charts off of this. And so this is kind of a nice, simple way to use these tags. Again, some of the partners with the solutions that we have there give you a lot more complexity, a lot better visibility of this and a lot more power. Finally, you get a very similar information from the usage API. And so this is just the usage API, puts it out in JSON format and then separated into CSV. And again, it gives you that same information. Here we're actually getting that information on an hourly basis. Then you can build some tooling around here to automate this and display that as you want, or work with some of the partners to actually give you a nice visual on that. Okay, so with that, I'm going to hand back over to Mahesh to take us through some of our next more complex templates.
All right, cool. Thanks, Drew. So what we're going to talk about is we briefly talked about templates and how you can leverage them, but we looked at some basic examples. Now let's look at the most common application that folks are interested in. We'll be talking about SharePoint today. And actually, how would you go about constructing a 4-tier app like SharePoint using templates, and how you can take some of the samples that we have already built to go rebuild on top. So as I mentioned earlier, when you start architecting a template or start building a template, the the most basic thing that we recommend people to do is take a look at a lot of our samples, take a look at some of the most common examples that matches your application, like are you doing a 2-tier, are you doing a 3-tier, or are you just focusing on the VMs? Take a look at some of these samples and re-leverage some of the code again, because it's very identical in most cases. Those patterns always exist, so look for those patterns or reach out and use the community to engage and get the right pattern. So when you architect a template, the way you need to think about it is try to break it down into infrastructure build-out and the in-VM application build-out. When you think about the infrastructure build-out, think about the number of VMs. What are the different environments that you're building it for? Are you building it for dev? Are you building it for test? Are you building it for prod? Think about that and actually have these different configurations in mind when you're architecting the first template. And then when you start building out these different files, think about infrastructure as a separate entity. Think about, hey, maybe I should have a separate file that will allow me to create my virtual network, a separate file that will allow me to set up my storage accounts, and then the actual deployment file that will allow me to go deploy my VM. So actually break them out, just like how you would write code or write a PowerShell script. Just think about them and break them out. The next part about the template files is really the in-VM configuration, because that's where the heavy lifting of configuring the app, setting up the app, configuring databases, striping the disks, all of that happens inside the VM, and you would usually be writing PowerShell scripts for them. Now you have the flexibility of using our extension platform to run these scripts inside the box and also express dependencies. And a good dependency, as I mentioned earlier, the script 2 depending on script 1, could think of it from an AD standpoint, right? You could have Active Directory primary and secondary DCs being set up. The secondary VM cannot join the primary DC until the primary DC is set up. So you can actually have the secondary DC script wait on the primary DC to be done and configured before then you can say go back and join to the primary DC now. So you can actually have these dependencies expressed. So think about writing these scripts in, like if you're doing a specific script, write them separately. But if you have a common script like I want to join to a domain, or like I want to install an app on 7 VMs, write these as common scripts that you can reuse again and again. So think about this from your VM configuration standpoint. Now, at a high level, the way we've broken it down is we've given some architecture reference of how you can think about these templates, but this is not the golden standard. You're absolutely allowed to go architect the template the way you love it, but this is a good example of how you can architect it so you can actually reuse these templates again and again. So we have this flexibility, and I'll show this briefly as well in the Azure Resource Manager, which allows you to link templates. So by this means, what you can do is you can actually have a set of these basic building block templates that you have, construct a master, and then just call them whenever you need to. So that's the advantage of using the template linking capability. And that's what we'll recommend here today as well. You can construct a master template that is actually going to call into a set of sub-templates, say for a dev environment or a test environment or a prod environment. And each one of those sub-templates is going to call back into, let's say, setting up the VMs. That could be a member resource template. Then the shared resource template could be setting up a virtual network or setting up a storage account. And then you have your common scripts that you can call into from the VM setup, or you can use a custom script that is setting up an app or setting up some specific application inside the VM. So that's how you break your app down and then architect it, draw a good architecture diagram, and then bring that back into the template representation. So SharePoint, most of you guys are aware of it. At a high level, it's a 4-tier app, and this is what we're going to look at, the template for it, and actually going to kick off a template deployment. At a high level, we'll start with an AD, ADDC. We'll set up 2 AD VMs, actually configure one of the primary and another the secondary. We'll set up SQL always on, right from a template file, which you get access to, so you can actually go single-click deploy a SQL always on VM going forward. It'll set up 2 VMs, for primary and secondary, and set up a witness. It'll go configure the failover cluster on top of it automatically. Once that is done, we'll express the dependency and then say, hey, now go spin up the web frontend and the app tier VMs for my SharePoint farm, and then go do in-VM configuration for setting up the app server and the SharePoint server. So all of this is just available in a single template file. And once this is ready, all that you have to do is to go deploy, specify the right parameters for your farm, and you get a single-click deploy of a SharePoint farm, which used to take months together. Now setting this up is actually very, very simple. Now you have the flexible, and we have done a basic deployment, obviously. So further configuration of the app inside the VM can be done by taking the script and actually modifying it further and say, hey, I need this configuration. Just change the script, and you've got your SharePoint form. So that's the flexibility that you get. Okay. So we're going to look at the template file, but at a high level, as I said, that was a reference architecture. That's not always the golden standard. We've followed a different model here. The Azure deploy.json actually contains the creation of all the resources. The way it works is we create a bunch of these VMs and then go set up the scripts on each one of them. So we set up the ADDC, then we actually go update the VNet with the DNS server name. Then we go configure the backup DC. Then we go make sure that the NICs also carry the DNS server names because it needs to carry the same IP address to ensure that the resolution happens. So we go do that. Then we start creating the file share witness. This is setting up the witness inside to make sure that the SQL always on cluster can work. Then we go prepare, set up SQL because it expects it to be set up on the cloud. So we go set up SQL on the box, configure it. Then we go ahead and create the failover cluster between the SQL server and the witnesses. Then we go kick off the SharePoint server deployment script. This is a common script that we use on all the different VMs that are part of SharePoint. And this is what we're going to do. Let's go ahead and start taking a look at it. Okay.
You're on.
Awesome. All right. So here's the SharePoint firm deployment. As you expected, it's a complicated template. You've got 44 parameters, 37 resources being deployed. So it is pretty powerful. And if you think about it, imagine this being done in a PowerShell script. And we used to have one of this, and it was like 4,000 lines of code or something like that. So all that you get, that flexibility right here in a single template file. And I'll show you a couple of samples of how we further simplified deploying large-scale VMs as well.
The other thing this changes, the old, if you had a big monolithic script of PowerShell, and you try to change it, make modifications, it was a very difficult process. It's very easy to break. It's very fragile. Even though these are big templates, we explicitly broke them out a large amount so that you can customize them, so you can configure them, which is really what we expect a lot of people to do. Take the base template, tailor it as they need, potentially upload it into GitHub if you want, but definitely use it for your deployments.
Absolutely. All right, so as you can see, there are a lot of parameters,
and we're going through here. Mahesh is using Visual Studio. Visual Studio is a great environment that supports this natively with the current set of cloud tools. But you can use any editor, JSON editor, that you like out there.
Yeah, absolutely. And I think, I'm not sure if you guys followed, but we also announced Visual Studio Code, which is a very good tool that was announced. You can actually use Visual Studio Code to go edit, and all of these JSON files, we have inbuilt capability to go do JSON editing right in Visual Studio Code as well. Okay, so what we are looking at is, it's a huge file. I'm not going to go through in detail. There are two key capabilities that I'm going to point out, though. The first capability that I'm going to look at is look for the looping capability, which we actually leveraged earlier. And I'm going to showcase that to you. So it's all going ahead. We're setting up the load balancers for the different things. We're setting up the network interfaces, joining them to the load balancer, making sure the configuration is ready. Okay, so actually let's look at this.
Of course, all this configuration is published up on our MSDN pages. This actually just follows the REST API. So our API documentation matches directly what you use in these template languages, a really one-to-one relationship.
Right, and another important thing is for each of these template files, given how complex, what we've done is we've also written documentation to explain how these templates file look like. What is the architecture that backs this template, and how can you go leverage it and make modifications for it. So we are going to put reference architecture, reference examples, reference samples for each one of these complicated applications, so you can actually easily leverage them versus looking at the file and trying to understand it. Okay, so the capability that I want to talk about was this section right here. This is a capability that is available in the template language called copy and copy index. What this does is specifying this in a particular resource type right here ensures that that resource gets created so many number of times. So the variable section actually accepts a value called number of SharePoint web VMs, and it's pre-configured right now to 2. But if you say, hey, I want to go put 4 or 10, what this will do is it'll automatically create 10 such resources for you. So you don't have to create or define 10 entities again and again, but you just have to specify this copy function inside the resource, and it'll actually and the Azure Resource Manager will take care of creating such number of VMs. And what happens here is we're doing this on the network interfaces. We can also do the same again on a public IP address or on a virtual machine. The way we will do it is, we have done this on the network interface. We'll do the same on the VM. And we have the capability, and I'll actually move to the VMs to actually show you how that reference really works. So this is creating a very complicated template. Right here. So if you look at this sample right here, what we've done is we're doing the looping on the VMs right now, and it is actually accepting the number of SQL VMs to go do the loop. And the important part here is if you look at it, we will be leveraging the capability of copy index even in our dependencies. We can say spinning up SQL VM 1 depends on spinning up SQL NIC 1. So you don't have to explicitly go find which one of these are, but if you use the looping capability, capability, you can actually define the references, define the dependencies just using the copy index capability. So you can say public IP 0 depends on NIC 0. You can say VM 0 depends on NIC 0 automatically in the language itself. You don't have to go explicitly orchestrate and write code for doing all of this dependency work, which you used to do before. So that's the power. The next thing that I do want to talk about is template link. So let me go search template link. So this is the template linking capability that I talked about earlier. What we're doing here with template links is you can, from within a master template, you can actually sub-branch and actually call into a bunch of secondary templates and execute them individually as well. So this allows you to break your code, break your app into multiple small pieces and actually have them execute in different model files. And breaking them into different template files makes it more manageable because you'll have these building blocks sitting there on the out, which allows you to reconstruct or recall them again and again. The configuration of spinning a virtual network for these environments is not going to drastically change every single time. So that's another advantage. You're saying, hey, I have my app, and I know always I go pre-configure 10 storage accounts. Putting that in a template file gives you the flexibility to actually redo this all over again. Okay? So those are two key capabilities that I want to talk about. This is a very complicated template. It's going to be up on GitHub. Do take a look at our documentation and go play with it. Another key thing that we've done with Visual Studio is you can deploy these template files right from Visual Studio as well, which is what I'm doing. I'm going to go ahead. Okay. Let me look at the parameters.json, make sure everything's good to go.
So one of the advantages is that by having this set of templates, again, the ISVs, whether that's SharePoint, whether that's SQL Team, Oracle, they can provide these default templates, these recommended templates that then you can just go and use. And so it takes a lot of the challenge out of this. You can just take the general recommendation and deploy. So,
right.
So here you're doing creating a resource.
I'm going ahead and creating the resource group where I'm going to deploy this. I'm creating it in East Asia. This resource group creation happens on the fly. And I'm going to choose the template that I'm going to deploy. This is my master template. This is the parameters file that I have. You can have a bunch of different parameters for your different environments. I can go edit these parameters file right here. I can go enter each one of these different values. I can go, for example, I can go change the password and say, okay, this is my password. Save the passwords file. What this does is it actually stores the file locally for you as well. So you can, next time you want to go use it for upgrade or anything, you actually have the files ready to go. And then you can just go say deploy.
So you just check all this into your source
control,
source control, and go. You have your secrets potentially stored in Key Vault, so the secrets are separated, but then your source is just source controlled.
Yep. All right. I think this is going to go launch. We'll wait for a little bit. I think it's going to just go ahead and create, check if the template is valid, and then start posting the template to go ahead and create the template deployment. While that's coming up, what I'm going to do is, since it's going to take an hour or two to get this set up, I'm not going to go wait for that. I think you guys will hate me. So I'm going to go switch back to, as you can see, the template is valid. It's posting the whole template again, and it'll start creating the resources one by one. So as you can see, the first resource is already created, and it's going to transition and start posting all of this resource for you on your behalf. So the whole template deployment and deploying a SharePoint form is fundamentally simplified. You can take it back home. You can modify it the way you want and deploy. Okay, now, given the time that we have, what I'm going to do is I'm going to switch to a deployment that I already had. Here's the SharePoint HA Ignite resource group that I've already created. You can go to the portal, view the entire set of resources. As you can see, it's a 9 VM SharePoint farm. Everything's deployed right here. We have the load balancers configured and the RDP sessions configured. I'm going to go look at all the resources that are here. As you can see, all the 9 VMs, the availability sets, the NICs that are needed for all of those 9 VMs, and the IP address, everything sits right here. So you can actually get a complete view of what the app is doing from a single-click view, right? What we are going to do is, now we are going to go to the front-end IP for the web form and look at the DNS name. If you look at it, it's actually this particular DNS name that we have right here. I'm going to go zoom in. It's CGS, CG SharePoint Ignite 1. Let's go back, hit that URL, and as you can see, this is the URL of the SharePoint form that I just deployed from a single click. It's available right there. I have an text file that's uploaded here. Just works, and that's SharePoint form in a single click for you guys.
Very cool. Thank you, Mahesh.
All right.
All right. So that shows a lot of the simplicity, and once you have that template created, that template right, it's awesome. It is really, really slick. I do want to talk a little bit briefly about if you're actually building out these templates yourself, some of the tools you use for debugging them. There's a set of things, template validation. So, first off, using a tool that actually does a JSON schema editor, such as Visual Studio, plugins for like Atom and other tools. So that gets you your right JSON format. Pretty simple. And then the test Azure VM, test Azure Resource Group template function in PowerShell does a validation and makes sure it matches all of the schema and the language of the template language for Resource Manager. Then we get into the resource group logging. I'm going to show you just quickly on how you see some of the logs in the portal. Of course, you can also do the same thing out of our command line interfaces, whether that's the Azure command line interface or the PowerShell tool. And then also REST API Explorer, which I'll just show you real quickly. So let's flip over here. So what we've done here, I deployed a template and I purposely set up a bad image. So I called this Windows bad, and of course it didn't find that in the platform. But what you can do is you can quickly come in here, and in here you've got a set of events. And if you actually click on your events, close that, it's not showing up. But here we're actually showing that in the last deployment, see it shows that it failed. You can click on here, it gives you the information about the template, the input parameters that I selected, and then you'll see in here pretty quickly as you drill down into it, here's the operation that failed, and the image reference was not found. It's because I put a bad image reference there. This is because if you think about it, you actually built this template. You were doing a large number of resources. You gave this template to the resource manager, and it's going out and deploying and creating resources. It's doing this as much parallelism as possible, but because it's all highly parallelized, you may have failures in different places, and it's not as simple just seeing the failures come back on the command line because you're not driving these yourself. So you really want to leverage this, the log file here, to get the details of what actually failed in the individual resource. But as you drill into this, as you drill into any of these error items, you can quickly find what went wrong, go back and change the template pretty quickly. The other piece I wanted to show, because it's all built on our REST APIs, this is the at resources.azure.com, or our ARM Explorer. This basically pulls back the Ibiza, the graphical portal, and actually just drills into it, and you can look at individual resources. So here I've got my resource group. I've got my, if I can drill down in here, I'd see that same bad image resource. And I could do things here. I can actually post configuration. I could actually go here and delete it if I want. By default, it's set to read only. If I flip this over to write, I could go through here and do create operations, delete operations. And so again, as you're going through and doing advanced deployment and configuration of your templates, this is a really nice thing to kind of leverage to jump into. So the last piece I really wanted to cover. All right, what happened here? Oh, switched to the wrong one. Okay. There we go. So the last piece I want to talk about, everything we've been going through today is actually available in production right now. I guess the one exception here is the API for usage and rate card. That's in private preview. Send an email to that email address to actually get access to that. However, this is all built and part of the foundation as we're calling the unified Azure stack. As was announced yesterday, we're building this common infrastructure that's going to apply both in public Azure, in private clouds, or in hosted clouds, all built on the same code base. And in fact, that resource manager that we've talked a lot about today, we've got additional sessions on resource manager, that's the heart of that. That same resource manager runs across all platforms, whether that's cloud or on-premises. The tooling built above that, Visual Studio, PowerShell, Azure CLI, those all can just be targeted at any cloud endpoint. The same tools that we use, the same Visual Studio tools that we're using to deploy that SharePoint template could be targeted at on-premise deployment and deploy that same template there on premises. So you really get that cross-premises capability and that power. The extensions, again, same extension model. And then where we get differences, these resource providers that plug in to provide those resources into Resource Manager. We've been talking about compute, networking, and storage. There's a large set of Azure resources, whether that's SQL DB, websites, and also third-party resources will plug in there under that Resource Manager. Those providers are the one piece when it comes into Azure and on-premises that we start seeing a little bit of difference. But the provider, if you think about the top half on the compute networking storage, is exactly the same code. And in fact, from the engineering team, we can comment that it's the same team working on the on-premises set of code and the Azure set of code. It's shared code in the top half of those providers. The only differences we see then is in the bottom half, where the fabric controller that we use in Azure, that's worldwide scale, is a little different than the fabric controller used on-premises. But the vast majority of this is all the same. Those templates that an ISV will author or that you author, you can leverage those in any of the unified Azure stack. You leverage the extensions and get that real, true hybrid capability. So today, we talked about what we have new with the IaaS v2. The scalability is amazing. What we showed here, 4 minutes to do 40 VMs. We've got a session later today, or later this week, that's going to take that much, much further, looking at our VM scalability into the hundreds and thousands of VMs to build some massive, massive workloads on here. The templates, as you've seen, the templates greatly simplify a very complex configuration. And then once you have those using the templates, the delegation capability through Resource Manager allows you to easily expand that out into your organization and then also get cost control around that. And then everything you have here will be done available both on the Azure side and on-premise through the unified Azure stack. So we have just a few minutes for some questions. There's also a set of other IaaS and compute-related sessions later today and through the week. Whether that, I will highlight the Getting Started. It's with our manager, Corey Sanders. That gives you kind of the intro, the broad strokes for IaaS. And so if you're new to IaaS, definitely want to hit that. We cover things like some of the application deployment, leveraging the large scale, as I mentioned, as well as getting into more of the open source, Linux-specific things, Docker, a lot of other pieces coming on later this week. So with that, I thank you so much for your time, and I hope this is very helpful for you.
Thanks, guys.